Now let's look at the Pythagorean Theorem. In a right triangle, the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. So we have side A here, side B, and side C. So one thing I want you to notice is that angles are usually written with capital letters and the sides are written with lowercase letters. Also to note is that if you have A here, the side opposite is a lowercase a. For B, so this is the angle B, the side opposite is a lowercase b. And then for C, it is C on this side. And so our symbols, if you remember the Pythagorean theorem, that is going to be a squared plus b squared equals c squared. So what we're going to do is we're going to find the length of a leg. So we're given 7 inches, x inches, and 14 inches. Now the most important thing to identify in right triangles is the hypotenuse. So it's important to identify what the hypotenuse is. A and B is fine, but the hypotenuse is important because then that changes what it could be if you identify the hypotenuse is incorrect. So it doesn't matter which one is A, which one is B. So I'll call this A, this is B, the hypotenuse is C. So again, that's always opposite of the right angle. So we have A squared plus B squared equals C squared. So we're looking at A is 7 squared plus B, we don't know what that is, so we're going to call it x squared equals 14 squared. So 7 squared we know is 49 plus x squared equals 14 squared. 14 squared is 196. So then let's solve. So let's subtract 49 from both sides to isolate our x. So we get x squared equals 147. Then we take the square root. And so we get x equals. Now normally we get plus or minus, but because we're looking at distance, we don't need the negative value. So therefore, this is just square root of 147. And this breaks down actually. So this is, we can divide 3 into it because I know 7, 8, 9, 10, 11, 12, right? So if I add 7 plus 4 plus 1, that's 12. So I know 3 goes into that. So if I divided it by 3, I am going to get 3 times 4 is 12. 27, 49. So this is actually square root of 3 times 49. And then 49 is really 7 times 7. So this simplifies to 7 square root of 3. So try these next 2 examples on your own. Try number 2 and number 3, please. So if you tried this out, for number 2, you should have gotten 4 square root of 3. For number 3, you have to do a little bit of work on that because it gives us the entire length of both triangles, which is 14. So it's really half. Notice that this is 8 and 8, so it's an isosceles triangle. And so B is going to be the same for both. You can see that with the measurement here. Now if this is 14, then it has to be cut in half. This is a right angle. And so this is going to be 7 and 7. So we realize that we can name this A squared is 7 plus b squared. We don't know what that is. We can call it b squared or x squared. And that equals 8 squared. Then we solve it. You get b equals square root of 15. Now the last thing I want to look at is to talk about special right triangles. So we're going to label the angles and sides of a 45, 45, 90 degree triangle and a 30, 60, 90 degree triangle. There's some special properties about those. Now if you remember them, then it makes it a lot easier. So because whenever you see 45, 45, 90, it makes it a lot faster to solve. So both of these, so number 1, this is 90 degrees, and therefore the other angles are 45 degrees and 45 degrees. Now remember, this is isosceles, and so these 2 measurements are the same. So if I call this x, it is also x here. Now in order to get to the other side, the hypotenuse, this is going to be x times square root of 2. Okay, so this is a special right triangle. So if you know one side of the triangle, you know the other side, the other leg, and then to hop to the hypotenuse, you're going to multiply by square root of 2. Now, hypotenuse is larger, so you're multiplying to get to that side. Now, if you're going from the hypotenuse to the leg, then you would have to divide by root 2 in order to get to the leg. Now, just look at this, for example. If this is x root 2 and we want to figure out this side, notice the difference between them. In order to get this x here, what we're going to do is divide it by root 2, right? And we get the x. So it's just knowing when do you multiply root 2 versus dividing by root 2. Now let's do the other side, 30, 60, 90 degree triangle. So first of all, I know this is 90 degrees for sure. Now we have to think about sides. So the smallest side is actually here. So therefore, if this is the smallest side, therefore the angle opposite it must be the smallest angle. So therefore this is 30 degrees here, and then this is 60 degrees here. Now, the special properties of this triangle is that the shortest leg, if we name that x, the hypotenuse is 2 times that shortest leg, 2 times x. Then here, to get to this leg here, you're going to multiply square root of 3 to x. So again, knowing these special properties of these special right triangles, 30, 60, 90, 45, 45, 90, and we memorize these, it makes it very, very helpful for us. You could use a Pythagorean theorem to try and solve for each of these pieces. You may have done this in geometry. We're talking about equilateral triangles and doing the proof of all that. So we will come back to the 30, 60, 90, 45, 45 degree, 90 degree triangles because they will come into play when we're looking at our unit circles, and we really are just looking at these special properties. Now, you are going to finish the homework on this side. So again, don't need to print the worksheet, just write this on your paper and then just showing all the work on there, numbering it so it's clear for me. Thank you.